Okay, this is the next question by Amina. The question is, which of these drops A, B, C or D would produce the loudest sound and which would produce the softer sound? Now, I don't know which one will give the loudest or softest because I've not done this experiment before, but I can infer from the sizes of the water droplets. So you can see that A and B are of the same height, but B is bigger than A in terms of its size. C and D are different heights. C is smaller in between B and D in terms of its height, but in terms of its size, it certainly is much smaller than B and much smaller than D. D, on the other hand, is about the same size as B, but because it is very close to the water, it is definitely different. So why is this question designed like this? Okay, now first of all, let's revise. We know that the higher an object is, the greater the gravitational potential energy. Okay, I do hope you remember this. This is a very important concept that you must know. Okay, the higher an object is, the greater the gravitational potential energy it has. Okay, alright, so this is the first part. So of these four, which one would have the higher gravitational potential energy? Obviously, from the height, A and B would have a higher gravitational potential energy compared to C and D. Alright? Now, what else do we know? We also know that a heavier object, okay, has more weight. Okay, a heavier object has more weight. Why? Because more gravity, because of gravity, right? A heavier object has more weight because has more weight because of more gravitational force acting on it. Alright, so one way to think of this is to, let's say we are on the 4th floor of our school building, just outside your class. If I were to drop a small ping pong ball, a light one, when it reaches the concrete floor, it will not cause a dent, alright, because it is very, very light. But if I were to drop a big bowling ball from the 4th floor of our building, I think it will cause a huge thud, right, because of the sound that is converted from the kinetic energy, as well as a huge dent on the concrete floor. Alright, because a heavier object has more weight, alright, because there's more gravitational force acting on it. Now, knowing that of these two, then, what do you think? Okay, wait, something went wrong here. More gravitational force. Okay, let me just finish it. Acting on the object. Okay, alright. Now, with that, we can tell that between A and B, it has the same gravitational potential energy that can be converted to kinetic. But we also know that B is heavier because it's bigger. So between A and B, which one will be louder when it hits the container of water? Remember, right? Okay, what we have is gravitational potential energy is converted to kinetic energy. Alright, so the more gravitational potential energy something has, the more kinetic energy it has too. Alright, so when A drops onto the water and B drops onto the water, and it's the same height. Now this is the same height. The reason why it is slanted like that is because I suspect Amina took a photo of it from a book, and therefore it is not so straight. Maybe I should just draw like that, okay, just to show how it should be straight. Okay, yeah, it should be straight. So this is the corrected one. Okay, it is slanted because of the way Amina took the photo. Now, so gravitational potential energy is converted to kinetic energy. So these two will have the same kinetic energy, but because this is bigger, it's going to have more weight, and therefore it will be converted to more sound energy. All right. Okay, again one more time. So if I were to just do that, it will be written like this, right? You know, right? Gravitational. Okay, I'm gonna write short form. Remember, you're not supposed to write short form in. You're supposed to spell it out full. Our potential energy is converted to kinetic energy. Okay, which is converted to sound energy, right? Okay, so the more gravitational potential energy it has between A, B, C, and D, A and B will have more gravitational potential energy, which will be converted to more kinetic energy, which will be converted to more sound energy. So here A and B will have more gravitational potential energy, so it will be definitely louder. So A and B will be louder than C and D. Okay, do you understand this? Okay. But between A and B, which one will be louder? It will be B, because B has more weight, right? B will be louder than A because it is bigger and has more weight that can be converted, alright, that can produce converted to sound. Okay, so we know this. Alright, so B will be louder. So if A, B, C, and D, A and B is louder than C and D, and B is louder than A, that makes B the loudest sound. Okay, so B will make the loudest sound as it hits the water. Now let's look at the softer sound then. Alright, what would the softer sound be? Okay, now please note that we know that C and D will be softer than A and B. Alright? Okay? Alright, and C and D, I think is almost the same height. I can't tell whether they are because of the way Amina took the photo. But if assuming that they are of the same height, C and D are of the same height or almost the same height, then C would be softer than D because C is much smaller. So if I were to draw a line like that, okay, to show them that they are almost the same height, okay, C would have a softer sound simply because it is smaller than D. So C and D would be the opposite. Okay, so I'm going to write like that, right? Something like that, okay? So C and D will be softer than A and B. As you can see, it is directly opposite of the first statement here. Alright, now C will be softer than B because it is smaller and has lesser weight. Okay, and therefore I hope I have explained your question, okay, as to why the answer is loudest B and softest C. Okay, thank you very much.